Okay, so we're doing chapter 9, problem 49. So it tells us the measure of inelasticity in a head-on collision is called the coefficient of restitution, and that's a parameter we call E here, given by this equation. So show that E equals 1, so part A says show that E equals 1 for a perfectly elastic collision, and E equals 0 for a completely inelastic collision. Okay. So equation 9.8 shows us the relation for velocity for perfectly elastic collisions, and that says VA equals, not VA equals, VA minus VB equals negative VA prime minus VB prime. So if we plug that into our equation for for the coefficient of restitution for an elastic collision, then we have negative VA minus VB over VB minus VA, and that's just 1, which is what we wanted to show. Okay. For completely inelastic collisions, we have the relation that VA prime equals VB prime, because that means the objects stick together and they're co-moving together finally. So if we plug this relation in, VA minus VA prime over VB minus VA, that's just 0, which again is what we wanted to show. Okay, cool. So let's move on to part B now. So part B says a simple method for measuring the coefficient of restitution for an object colliding with a very hard surface like steel is to drop the object onto a heavy steel plate. Just this is what we have shown over here on the right. So it says determine a formula for E in terms of the original height and maximum height reached after the collision. Okay, so in this case, we know that VB equals VB prime equals 0 because the steel plate doesn't move. Okay, so that means we know that E is just VA, negative VA prime over VA. Okay. So just as before, we can use energy conservation to write VA, which is just before the collision. So we know that the potential energy at height h is going to equal the kinetic energy just before. We also know that the potential energy at height h prime is going to equal the kinetic energy right after. So both of these gives us a relation for VA, and that's given by square root of 2gh, and VA prime is negative square root of 2gh prime. Okay, so now we can plug these into our equation for the E value. So we have square root of 2gh prime over square root of 2gh. Well, 2g's cancel out, and this is just square root of h prime over h. And that's what we wanted to show. Cool.